Hi, Mrs. is going to be working through homework number 8, which is the worksheet titled Simplifying Numerical and Variable Expressions Through Discovery. And I'm going to explain example 1 and 2 and also work out problems 1 and 3 from this page, and then I'll do the back page. So feel free to pause and fast forward any parts that you wish to see first. So in example 1 here, you will notice that I have 5 to the 4th power over 5 to the 2nd. I know that 5 to the 4th power means 5 times 5 to 5 times 5, and I expanded that. So this is the expanded form. There's a little typo here. And then 5 to the 2nd power gave me 5 times 5. I realized that 5 over 5, when I look at that part, 5 over 5 is the same. When I simplify that, that equals to 1. So I can cross those out and write 1 and 1. I can cross out another 5 and 5 and get 1 and 1. And that's about it that I can cross out. And so I still have 1, 1. I could choose to, cross them out with a straight line like that through them if I want to. But what I will get in my numerator left over is 5 times 5. And in my denominator, I have just a 1. And then when I work out 5 times 5, I get 25, and that would be my answer. So that's the way to do it through the expanded form. And this would be considered method 1. Now method 1 would be the safest method to use. So we say, when in doubt, expand and cross out. So it's best to just expand them, cross them out as you simplify, and then get to your answer. Now the second method that you might take would be actually the easier method, but sometimes hard to remember through a long period of time what those exponent rules are. So we're using exponent rules for here. Here you will see in example number 1, 5 to the 4th power over 5 to the 2nd power. I would work it out by writing 5. So what you see is that I keep the base number. So the base number in the division simplifying fraction problem is going to be 5. So I keep the 5. Seems like that I have 4 minus a 2, and it seems like 4 came from the exponent and the 2 in the exponent from the question itself. Now, how about the subtraction sign? Well, in subtraction, I'm subtracting because I think when I'm doing expanded form, I notice that the 5 and the 5, when I cancel it out, if I cancel something out, it's like taking it away. Take away. Away. And because I'm going to take that away, when I cancel something away, I would subtract it. So it seems that when I was doing it over here, I had 4 at the numerator and then 2 5s in the denominator. I crossed 2 in them out, and it seemed like I did have 2 left. So what it shows here is that 4 minus 2 does give me the exponent 2, and so I have 5 to the 2nd power, which is the same as saying 5 times 5, which then gave me the answer 25, which was really the answer I had gotten the first time when using method 1. So it seems like that might be a shortcut strategy that I could use as long as I remember that strategy. Here again in example 2, I'm again dividing powers. I have 5 to the 2nd power, 5 to the 4th power. I expanded that out, 5 times 5 in the numerator, 5 times 5 times 5 times 5 in the denominator. I could cross out 5, 5. 5 divided by 5 is 1. So here I have 1 and 1, 1 and 1. So if I do 1 times 1, that's going to give me the 1 right here. I have a 5 times 5 left in the denominator, and then that gives me 1 over 25. So I will be getting a fraction answer for number 2, example 2. When I use method 2 by using the exponent rules, I'm going to keep the base number. Okay, so the base number should stay the same, which is 5, so I do have 5. Now the exponents, rather than what I did earlier, I subtracted 4 minus 2. This time I'm subtracting 2 minus 4, because in the questions, the exponent 2 and the 4 is switched. So it seems like I have to go from top to bottom, so I'm going to do 2 minus 4, because I am, again, going to cancel them away, so I am subtracting. So when I do 2 minus 4, I get negative 2. And if I apply what I learned about negative exponents, remember that that negative exponent means that my answer will be the reciprocal answer of whatever I get for the positive answer. So the positive answer for 5 positive 2 would be 5 to the second power. I'm going to write it over here, which would be 25. So if I just take the reciprocal of that, that's how I get the answer 1 over 25, which is my final answer for this question. I'm going to work on number 1 and 3, and then I will continue to the back side of the worksheet. Example 1, or problem number 1, I'm going to expand it out by writing 2 times 2 times 2, because 2 to the third power means 2, 2, 2. In my denominator, I do have 1, 2, so there is a 1 right here that I'm going to write because I will be needing it later. If I cross out a 2 and a 2. What I have left is 2 times 2, and in my denominator, I do have a 1. This represents a 1, okay, a 1. Right. And then 2 times 2 would give me the answer 4 over 1, and 4 over 1 can just be simplified to really just 4. If I use method 2, if I look at my problem, the base number is 2, so I'm going to keep the base, stays the same. Okay, so 2. I will, seems like I should be subtracting because I'm canceling them out. So I'm going to subtract 3 minus 1 in that specific order. And then I will get the 2 base, still stays the same. And then I'm going to subtract the 3 minus 2, which is 2. And then 2 to the second power is the same as 2 times 2. And 2 times 2 is 4, the answer I did first get. And so I know that that is also correct. For example, problem number 3. I'm going to expand out both the numerator and the denominator. I get 2 times 2 times 2. In my denominator, I get the same thing. I'm going to cross out, one by one, I'm going to cross out 1 and a 1. That simplifies. 2 and 2 makes 1 and 1. 1 and 1. 1 and 1. So what I have in my numerator is 1 times 1 times 1. In my denominator, when I simplified, I have another 1 times 1 times 1. That simplifies to 1 over 1, which is really just the answer 1. And for the using exponent rules, I'm actually going to take 2 as my base. I keep my base, so my base is 2. And then remember, I'm going to subtract my exponents. So I'm going to take the exponents 3 and 3. So I'm going to subtract 3 minus 3. Sometimes I can do that in my head. And I can write my base 2, stays the same. And if I subtract 3 minus 3, I will get the number 0. And now we have to think about what we learned about a 0 exponent. What would my answer be? Awesome, the answer would be equal to 1, because all numbers, regardless of the base number, if the exponent is 0, then my power will equal to 1. Perfect. On the back side of the worksheet, there are examples to the left side, and then 2 questions for you to try. The first starts out pretty simple, and if you don't want to show as much work as they did, they really show you step by step by step. So this would be the first step, the second step, the third step. Okay, remember that if my exponent is negative, like I had done in class, then I'm looking for the reciprocal of the positive exponent answer. Okay, so what would this question, I wrote it as a fraction, 11 over 1, with the negative 1. So I'm really just writing the number 11 as a fraction because I want to take the reciprocal. So the second step, I'm going to take the reciprocal, flip it around, 1 over 11, do the and then change the negative exponent to a positive exponent. So really down here, I'm just going to do a positive 1 down here. So my final answer would actually just be 1 over 11. Okay. And you go ahead and try the last column by yourself. I will not do that one for you in this YouTube video. For example number 2, you'll see that I did make a few little comments here about the number -2. First it was written as a fraction, then it was the reciprocal was taken in the parentheses, the -1 changed to a positive 1, and then my answer was just the fraction itself. So you can kind of see very lightly right here, it's a reciprocal, the fraction number. We do take the reciprocal. So same thing here, we're going to take -5, put it over 1, and that's a -1 exponent. I will take the reciprocal. So the reciprocal would be 1 over -5. And the exponent now is, rather than -1, it's going to be a +1 exponent, +1. So it doesn't, the +1 doesn't change my answer very much. It's just going to be 1 over -5 is my final answer. And the last example has quite a bit of numbers. The example shows t -2. And so really throughout the whole thing, you'll see the 5 stays the same. 5, 5. 5 never changes because the 5 is not affected by the -2 at all. The -2 exponent is only for t, which is really different. All right, that stays the same, which is really different than the first question I want you to try, which is that 5t is in the parentheses. So if 5t is in the parentheses, then 5t will go to the -2 second power, negative second power. So what it will look like is, remember we have to make this a reciprocal. Okay, so to do that, I'm going to first write it over 1. So it will be 1 over 5t. Okay. The exponent right now is -2. I'm just going to keep the parentheses, keep the -2. But this time, after I make it the reciprocal, which is down here, then I'm going to change that exponent, -2, to a +2. Okay. And you know, I'm just going to keep that 2 with the 5t down here. Okay, so I could actually bring the whole thing. So I still have a 1 in the denominator, and in my numerator, I am going to take 5t to the second. That means 5t times 5t. And then when I simplify that, I get 1 in my numerator. My denominator is now, I have 5 times 5, which gives me 25. And then t times t gives me t squared, so t squared. So this would be my final answer for that problem. I hope you have a good time working out the other questions, and I will spend time tomorrow, the whole class period, going over one of our new things for this week and also going over this worksheet. Please make sure that you study for your quiz coming up on Friday, all about exponents, so including everything in this worksheet and the worksheets we've done so far. So please keep all of your papers with you.